Hello everyone and welcome to this lecture. In this lecture, we are going to continue with the classifier model's key performance indicators or KPIs. If you guys remember in the previous lecture, we have been able to perform a quick review of confusion matrices, and we have been also able to introduce two new definitions to us, and these are precision and recall. We also went through a quick example where we have been able to show that classification accuracy only is not sufficient to assess model performance. We have to be, I would say, a little bit smarter. We have to take a look at additional KPIs such as precision and recall to have the full picture. So what I'm going to do right now is I wanted to show you guys kind of what we call it like a deep dive into precision and recall, and go through two key examples, and that will be part of the mini challenge. Okay, so if you guys remember, precision was true positives divided by the total true predictions. Again, let's take a look at our numbers. We assume that here we have the true positives were 1, true negatives were 90, false positives were 1, and false negatives were 8. And what we could do here is that we can simply calculate the precision. So simply, I'm going to divide true positives divided by true positives plus false positives. So 1, which is 1 here, divided by 1 plus 1. Okay, so 1 over 2 equals to 50%. So let's cover the definition again. Precision is a measure of correct positives. So in this example, the model predicted 2 patients were positive classes or has cancer. One of them was right, one of them was correct, and the other one was messed up, was false. So precision is an important metric when false positives are important. Simply, how many times a model says, let's say a pedestrian, for example, was detected and there was nothing there, okay? An example as well for the precision is when we do, let's say, drug testing, for example. And we're going to cover, again, a detailed example coming up in the mini challenge. Okay, so let's cover the recall deep dive. So if you guys remember, here again, we have the same numbers. This is the model performance, essentially. And recall is simply true positives, which is what we got here, divided by the column, divided by true positives plus false negatives. So 1 divided by 1 plus 8, which is 9, will give me 11%. So recall is also called the true positive rate or sensitivity. And in this example, if you guys remember, I had 9 cancer patients, and the model was only able to detect 1 of them. And essentially, recall is an important metric when we care about false negatives. Basically, when we care about how many of those 9 patients I was able to detect, that's when we care about recall, okay? And example of that, again, is self-driving cars and also fraud detection as well, okay? All right, so now it's time for a quick mini challenge that actually consists of 2 questions. The first question is, let's assume that you work as a data scientist at a bank, and you have been assigned to develop a fraud detection algorithm that could detect and block fraudulent transactions. And this is simply a binary classification problem. What I want you guys to do is, as a data scientist, could you please tell me what KPIs would you optimize? Do you optimize precision or do you optimize recall? And I want you to plot a 2x2 confusion matrix, and I want you to list out all the various scenarios, like what actually happened. Let's say when a true positive occur, true negative occur, and so on. Just explain to me what's actually happening in the 4 quadrants of the confusion matrix. And question number 2, which is kind of an extension of that, I want you to assume that you work also as a data scientist at, let's say, Google, and you work, let's say, on Gmail, product. And you have been working on a project to detect spam and ham emails. So when I say ham emails, that means these are legitimate emails. Spam emails, these are the spammy ones that is asking you for your username or password, or they ask you to like for money, for example. And this is again a binary classification problem. And the algorithm should be able to automatically detect and block spam emails. That's when the algorithm does it right, okay? So I want you guys to tell me as well, what KPIs would you optimize? Would you optimize precision or recall? And could you please also plot for me a 2x2 confusion matrix and list out all the various scenarios? Like what actually happens when true positives occur, or maybe when true negatives occur. And why do you care about precision or recall in both of these examples? So please go ahead, pause the video, attempt to solve the mini challenge, and I will see you guys after the break. All right, hope you guys were able to figure out the challenge. Let's go ahead and discuss the solution. Okay, so let's cover the bank fraud detection first. Okay, so as a bank, okay, the answer to the first question is, well, the bank, if you work as a data scientist at a bank, you try to optimize recall. Why is that? Let's cover the details. So let's assume that again, you are designing an algorithm to detect fraudulent transactions. Well, so if the model predicted that a given transaction was fraudulent transaction, so it was positive, and in real life, the transaction was actually positive, well, that means there was a fraud. So people was actually trying to steal, or use someone else's credit card, for example. And the model predicted that it was fraud. So the model actually was good. That means the transaction has been blocked. That's amazing, okay? So that's what we call it true positives. Here, that's when the transaction was actually non-fraudulent, so there was no fraud. So it was a normal transaction. And the model predicted no fraud. That's a good thing, okay? So now we're perfect. So again, when it comes to the diagonal element here, that's when the model predictions matches what actually happened in real life. Now to the troubles, now to the problem. Now, the model predicted positive, so the model says there is a fraud. However, in real life, well, there was no fraud. It was just a normal transaction, legitimate transaction made by, let's say, the owner of the credit card, basically. And it actually happened to me a lot. Let's say when I'm, for example, traveling, somewhere else. In general, the first transaction that I use when I travel somewhere, let's say anywhere away, let's say 1,000 kilometers, for example, away from my house, that's when I do any transaction, the bank blocks it and claims it's a fraudulent transaction. And the scenario here is that, well, it's a normal person, normal customer, trying to use his credit card, but the bank blocked it, okay? And maybe send you a message or telling you, please verify that transaction. And that's what we call it false positives. And we marked here this one as orange because, well, we have a pissed off customer. If that happens a lot, we can have a pissed off customer, but the bank is okay. And that's what we care about. Like from a financial standpoint, the bank did not lose any money, right? And that's why here, when it comes to precision, the bank also cares about precision, of course, but not as the same level as recall, which is coming up right now. Okay, so when it comes to here, to the this example here, that's when the model predicted negative. So the model said, well, no problem, this transaction is fine. However, in real life, it was actually positive. It was actually fraudulent transaction. So there was someone took a credit card from someone else and went there and bought like Bitcoin with it, for example, okay? So that was a fraudulent transaction. So there was fraud and the model predicted no fraud. The model said, you know what, that's a good transaction. That's a legitimate transaction. And that's a problem. That's a huge problem. And we mark it in red. Why? Because in this example, the bank actually loses money, okay? So, and that's why in this example here, the bank cares about recall a lot more compared to precision, because when the model messes up in this example here, the bank loses money, and that's a huge, of course, KPI that the bank tracks as well. Okay, so let's take a look at another example. Let's assume that now we have the spam email detection algorithm. Okay, let's again cover it in details. Well, if the model predicted positive, and in real life, it was positive, that's a good thing. So here, there was a spam email, and the model predicted spam as well. So, well, the transaction, or like, I don't want to say the transaction, the actual email, okay, was spam email. And the model said that was spam and maybe blocked the email and everything is good. We're happy here. Here, in this example, well, there was no spam email, so everything was good. And the model predicted no spam. So that's a good thing. That means the email went to inbox. So no problem as well. Now to the troubles. Here, the model predicted positive. So the model said there was a spam, right? However, in real life, the model, essentially, the email was fine. So there was no spam email. So it's actual legitimate email. However, what happened here is that the model predicted it's a spam email and it blocked it. And that's a huge problem here. What if you have, for example, let's say your dream job, let's say notification email. Maybe you have a critical email coming from a bank, for example, or come from a loved one, or coming from coworker. And then, you know, like it has been blocked or classified as spam and it went to the spam folder and you never heard about it, okay? And I actually have a lot of stories about this as well. And that's a huge problem here, right? And that's why when it comes to the spam email detection, we actually care about precision a lot more than recall. We actually say, when you actually say that this email is spam email, you need to be precise, okay? You can't mess that up. And the last example here, that's when the prediction was negative and the true class was positive, which means there was a spam email, right? So it was positive. However, the model predicted no spam. So it went to the inbox. Basically, you ended up with a spammy email to your inbox. And that's, again, I don't want to say it's not a big deal, but it's, again, it's like the customer wasn't pissed off. And if the customer just avoid the spam email, that's it. You know, it's not a big deal, I would say. But here, that's a big problem. That means you might block an important email, or maybe like a dream job notification, for example, or maybe an interview notification, and that would be a huge deal, okay? So that's a case when we care about precision, and it's okay if we mess up recall a little bit. All right, okay. So that's all I have for this lecture. I hope you guys enjoyed it. In the next lecture, let's go ahead and cover a very important concept in AI and machine learning in general, which is known as transfer learning. And please note that what I'm covering here, that these topics are, again, I would say quite advanced, like very close to advanced. So that will not going to impact, I would say, your ability to build the model with teachable machines. But if you guys wanted to take your knowledge step further and actually understand what's actually happening behind the scenes, that's why I'm covering these topics, and that will be extremely important if you plan to work in the AI field, if you're a programmer or non-programmer as well. So that's all I have. I hope you guys enjoyed this lecture, and see you in the next one.